Hey everyone, welcome back to the channel. I'm super pumped to have you here today. If you are into learning cool new technologies and building fast modern apps, you are in the right place. Today we are going to check out something that's shaking up the way apps talk to each other. Picture this: your apps, no matter what language they're written in or what platform they're running on, talking to each other easily and doing it way faster than you'd expect. It sounds awesome. That's exactly what gRPC does. In this video we talk about actually we will talk about what gRPC is, why it's such a big deal, and how it's making app communication faster and smarter in today's world of distributed systems. So what's gRPC all about? gRPC stands for Google Remote Procedure Call. It's an open source framework made by Google that lets apps call each other's functions or methods even if they're running on completely different systems or built with different programming languages. Think of it like a super efficient way for your services to have a conversation. Why go for gRPC? At the heart of gRPC is something called protocol buffers. This is basically a super compact and efficient format that gRPC uses to send data. Compared to REST APIs that rely on JSON, gRPC is faster and more lightweight, perfect for when you need speed and efficiency. But there is more. gRPC uses strict typing with protobuf schemas, which helps catch mistakes early and keeps communication between the client and server consistent. Plus, it's multi-language friendly, meaning it works great in systems with a mix of languages like C#, Java, Python, or Go. One of the coolest features is real-time streaming. Unlike REST, which is all about request response, gRPC supports two-way communication, so both the client and server can send and receive data in real time. Think chat apps, live monitoring, or even financial trading. And this is where gRPC really shines. And here's the cherry on top. gRPC makes your life easier by automatically generating a lot of the boilerplate code for clients and servers using the protobuf files. That means less manual coding, fewer errors, and faster development. Where is gRPC being used? You will see gRPC in action in a bunch of places like microservices for super fast communication between services, IoT devices, when bandwidth is tight and every byte counts, real-time apps like chat systems or live streaming, cross-language systems when you've got a mix of programming languages working together. In this video, I'll walk you through everything step by step: how to set up gRPC, define protobuf files, create your server, and implement real-world CRUD example. By the end, you'll see why gRPC is becoming a go-to choice for building modern apps. Before we dive into the code, I want to let you know that you can download this project directly from my GitHub account. The link to the project is provided below in the description, so feel free to check it out and follow along as we go through the implementation. And while you are at it, if you are enjoying the content, don't forget to hit the like button, subscribe, and drop a comment if you have any question or suggestion for future videos. Alright, let's get started with the code. Alright, let's get started. We are going to create a gRPC project using .NET 9. I'll walk you through all the ways you can get it done. Okay, let's go. Open Visual Studio, fire it up like you are about to do some serious coding. Click create a new project, and in the search bar type gRPC. You'll see something like ASP.NET Core gRPC service. Select that and hit next. Here give your project a name, something simple like gRPC project, something like that. Choose a location to save it, and don't forget to tick the use .NET 9 checkbox if it's not selected automatically. Okay, please wait. Okay, your gRPC project is born. Visual Studio will handle all the boring setup for you. Okay, sometimes after creating a gRPC project, you might encounter one or two errors in your program.cs file. Let me open this file and show you. Unfortunately, this time we didn't come across these types of problems, but occasionally these two lines, this line and this line, can raise errors because the required package hasn't been installed. To fix this, you need to install the package manually using the terminal or the NuGet package manager in Visual Studio. The package you need is grpc.asp.NET Core. Okay, now that we have configured the project, let's talk about the other parts of the project. When you create a gRPC project, two key folders are automatically set up: portals and services. These are essential to how gRPC works. Let's take a look at them one by one. This folder contains a portal files. Think of that portal files as blueprints for your gRPC services. They define what services you have, for example, a greeter service, what method your service expose, like say hello, and what data send and receive, such as hello request and hello reply. uh, Here's what your get.protofiles does. This line tells gRPC to use the latest version of the protocol buffers language, and this line ensures that the generated code for C# goes into the gRPC project namespace. And finally, greeter is your service. Say hello is a method within this service. It takes a hello request message and returns a hello reply message. Hello request is the input where the user sends their parameters such as a name. Hello reply is the output where the server sends a message back. For example, like hello John. Now, what about services folder? This folder contains the actual implementation of your services. It's where you write the logic for what your gRPC service will do. It inherits from greeter base. The greeter base class is automatically generated by gRPC based on your grid.portal file. It provides a base for your service, and you override its method to add custom behavior. For example, if you create a portal file and name it person, a base class with the name person will be generated in this path. Now that we've configured our basic gRPC project, I'm switching over to another project that's been implemented using Kylin architecture for a simple CRUD system. Don't worry if you are not familiar with Kylin architecture. This is a simple example, and I'll guide you step by step. If you want to dive deeper into this structure, I've added a helpful link above for you to check out. Now let's have a quick glance at the structure before focusing on our protofile, services, and testing. In the core layer, we have our main domain entities. For example, we have this person class, which represents the data structure we will work within this CRUD system. This class defines the fields for a person, like their name, ID, and date of birth, for example. It's straightforward and acts as the foundation for everything else in the project. Next up is the infrastructure layer, where we handle the actual data access and persistence. Application DB context class is our bridge to the database, using entity framework to manage entities like person. Person repository is where we define the methods for interacting with our person data, like adding, updating, retrieving, or deleting a person. Instead of directly working with the database, the rest of the project communicates with the repository, keeping things clean and modular. In the application layer, things get interesting. This is a data transfer object that defines what data gets sent between different layers. It's like a lighter version of the person entity, containing only the fields we need to send over the network or between parts of the app. Person validator makes sure our input is valid. We use fluent validation here. For example, we can check that names aren't empty, the national code is the right format, or the date of the birth makes sense. Fluent validation makes these checks super easy to implement and maintain. And finally, person service is the actual service that handle business logic, like validating input or orchestrating multiple repository calls. This structure might sound complex at first, but trust me, it's simple and logical once you break it down. Again, if this is new to you, take a look at the video I provided below in the description to learn more. It's definitely worth exploring. All right. Now that you've gained some knowledge and insight into this structure, let's move on and create our profile for a simple CRUD operation using person service. This will be the foundation for our gRPC communication, so let's dive right in. We had a quick look at the structure of our Killing architecture project. Now let's dive into creating our profile. This file will define the communication structure for our gRPC services. Here's what we will do. First, we will create a new file called person proto dot porto. Okay, let's begin by defining the syntax. Uh, Here, port 3 specifies the version of protocol buffers syntax we are using. Next, we set the C# underline namespace option. This maps the generated C# classes to a specific namespace. This is our main service, person service, which defines several RPC methods for CRUD operation. First is create person for adding a new person. Second, get person by ID for retrieving a person by their unique ID, and then get all persons for retrieving all persons. After that, update person for modifying an existing person, and finally delete person for removing a person. Uh, each method uses request and response messages. Let's define those. Okay, create person request. This message contains the details needed to create a person, such as first name, last name, national code, and date of birth. All fields are of type string. Second is create person response. This contains a single field success of type bool, which indicates whether the operation succeeded. After that, get person by ID request. This contains the ID of the person to retrieve, and then get person by ID response. This contains all the details of the person similar to the fields in the create person request. And get all person request. This is empty since no input is needed to retrieve all persons. And finally, get all persons response. This contains a repeated field which is like a list or array in other languages. It holds multiple person objects. Alright, now that we've gone through the profile step by step, I'll complete it for you, and then we will move on the person gRPC service implementation to see how these definitions come to life in our gRPC service. Let's go. Okay, as I mentioned before, I have now completed this file. I added the other requests and responses, such as update person request and update person response for update person method, delete person request and delete person response, and finally person, which is our model or entity. And once again, let me quickly explain this person service.porto file for you. Here we have our service that called person service includes five RPC methods such as create person, get person by ID, get all persons, and others. Each of these methods has a request and response model or parameter. As you learned earlier, this is our input model or parameter, and this one is our output model or parameter. For example, here we return a model as the output, whereas here we simply return a boolean value as the output. To summarize, this file defines a complete set of RPC methods and messages for a simple CRUD operation on the person entity. Now that is person service.proto file is ready, let's move on to implementing the person gRPC service, where we will bring this definition to life. Okay, now that you understand how the protofile works, let's switch to the person gRPC service file. This file in a way works like a controller in REST API project. It's the place where external calls land first, and it decides what happens next. For example, if someone wants to create a person or get a person by ID, they'll call their respective methods in this file. Think of it like a gatekeeper. It handles requests, calls the business logic, and sends back a response. Now let's compare person gRPC service with something like person controller in a REST API. Both serve a similar purpose. They are entry points for your application, but the way they work is slightly different. In a controller, you work with HTTP protocols. You are mapping things like post or get to a specific endpoints. But in person gRPC service, we are working with gRPC and protocol buffers, which communicate over HTTP2 and are much faster because of the binary serialization. Another difference is how we send and receive data. With REST, it's usually JSON, while with gRPC, it's these structured protobuf messages that you saw earlier in the protofile. And for handling errors, a controller usually relies on HTTP status code, but here in gRPC we work with a status code like OK, not found, or internal. But fundamentally both are doing the same job, taking a request, processing it, and sending a response. Alright, let's talk about the person gRPC service file itself. This class inherits from something called person service base. Now, where does that come from? It's generated automatically based on your protofile. So if you remember all those RPC methods we defined, like create person, get person by ID, and so on, those have their base definitions here in person service base, and our person gRPC service builds on that. Let me show you an example. Here's the create person method in person gRPC service. See what's happening here. When a create person request comes in, it calls the create person async method in our service layer and passes in a person DTO mapped from the request data. Once it gets the result, whether the operation was successful or not, it wraps it into a create person response and sends it back. This is very similar to what a controller does in a REST API, but instead of HTTP requests and response, we are using gRPC requests and responses. Finally, testing these methods with Postman is a bit different from how you test a REST API. We are not sending HTTP verbs and JSON data here. Instead, we are working with binary encoded protobuf messages, and Postman now supports gRPC, so we will walk through how to set that up and make calls in the next part of this tutorial. Let's move on. Alright, now that we've set up our gRPC services, it's time to test them on Postman. Let's start by testing the create person method in the person gRPC service. I'll guide you step by step through the process. This is going to be fun, so let's dive in. Before we run the application and open Postman, let's first set a breakpoint in our create person method in person gRPC service. Once the breakpoint is set, it will allow us to pause the execution and inspect the incoming data as the method runs. Debugging is super useful for ensuring everything works as expected. And now you can run the application and test your services. Testing gRPC services in Postman is slightly different from REST APIs. Unlike REST, where you use HTTP methods like POST or GET, with gRPC you directly interact with service methods defined in your protofile. Here's how to test create person step by step. Open Postman and click on new tab to start a new request. Instead of selecting HTTP, go to the gRPC option. If you don't see this, make sure you've updated Postman to the latest version that supports gRPC. In the URL field, type in your gRPC server address. If you are running it locally, it will look something like this. Make sure you are using the correct port for your gRPC server. After entering the server URL, click here and choose this option to select the protofile. Here you should select a person protofile which you have created it before and wrote your services and RPC methods into it. After selecting, it automatically detects all your services. Now you can choose create person method, and then in the gRPC message section you will need to define the request message. For create person, it should look something like this. Make sure the field match exactly with the create person request model defined in the protofile. Hit the invoke button to invoke the create person method. First, we jump into the breakpoint. While Postman is sending the request, your breakpoint in the create person method will trigger. At this point, you can inspect the request object to see the data being passed. For example, you can check if first name, last name, national code, and date of birth are populated correctly. Step through the code line by line to ensure the logic is being executed as expected. Once done, let the program continue to see the response in Postman. If everything is working, you'll receive a response like this. Once we've tested the create person method, we can apply the same process to other methods like get person by ID. This method allows us to fetch details about a specific person using their unique ID. I'll walk you through the entire process step by step, just like we did for create person. Let's get started. Before we test get person by ID method, let's set a breakpoint in this method in our person gRPC service. This will let us pause execution and check if the ID is being passed correctly and if our logic is working as intended. Open Postman and go to the gRPC tab just like before. Make sure your server is still running and enter the gRPC server URL. Postman will fetch the available services and methods. From the person service, select the get person by ID method. In the message tab, we need to provide the ID of the person we want to retrieve. This ID corresponds to the unique identifier of a person in your database. Replace one with an actual ID that exists, especially if you've just added a person using the create person method. Click invoke and Postman will invoke the get person by ID method. When the request hits your server, the breakpoint in get person by ID will trigger. You can hit F5 to continue the process. If everything is set up correctly, you will receive a response like this. Testing get person by ID in gRPC is similar to making a get request in REST API, but the key difference is that gRPC directly maps the proto message to the request and response. With REST, you'd typically use a URL like this. In gRPC, the method name and request structure are defined by the protofile, making it cleaner and more structured. Once we've confirmed the get person by ID method works perfectly, we can move on to testing other methods like get all persons, update persons, and delete persons. And they follow a similar process but with different request and response formats. Alright folks, now that we've tested our gRPC services and explored how everything works together, let's wrap this up. gRPC is a game changer for modern APIs. It's fast, efficient, and built for real-time communication between systems. Unlike traditional REST APIs, gRPC uses HTTP2 under the hood, which supports multiplexing and streaming, making it perfect for scenarios that demand high performance and low latency. But remember, gRPC might not always be the best fit for every project. If your app needs a widespread compatibility with web browsers or has simpler communication needs, REST could still be a better choice. That said, if you are building scalable, high-performance systems or microservices, gRPC can take your API design to the next level. So go ahead, explore more, and start implementing gRPC in your next project. At the end, thank you for sticking around. If you found this tutorial helpful, make sure to like and subscribe for more programming content. See you in the next one, and cheers.